All right, we have a little maintenance issue on the Mitsubishi horizontal to take care of here. And this is part of what it is. The high pressure coolant system has had a problem, and I started to take the pump apart that it came with, and my intention was to rebuild the pump. But once I got into the pump and the price of everything and all that, I decided I'd just replace the pump this time. The coolant system on this machine is like, I don't know, it's like maybe 20-something years old, maybe about 24, 25 years old, and it's never really had anything done to it. And this is the manufacturer type of pump that was in it, but I couldn't exactly get a replacement pump, the exact model of pump, so I tried to come as close as possible to what was there to replace it. And this is what I came up with. I couldn't go, I thought about increasing the volume, but in reality it would just overload the motor. This is run by a 5 horsepower motor. I'll show you that in a minute on the pump here. And if you start increasing the volume of the pump, it increases the power of the motor. So I didn't want to have to replace the motor or have problems with it stalling or overloading. So this is a pump that's very similar. In fact, let me go get the old one, because I'm going to have to change the base anyway. Okay, this is the pump that was in the unit. And these two pumps are almost identical to each other. The frame itself is identical, which is what I was really looking for, so I could just take the base angles off of this pump and mount it, and the shaft height and everything would match the motor, because it takes this flex coupling right directly to the motor. I didn't want to have to work with changing the height of things and everything. So first, but like I said before, I was starting to disassemble this pump here in order to, with the thought of rebuilding it, and I might still do that eventually. But I was having difficulty getting it apart to begin with, because I think they assembled this thing with Loctite on all these things, and it was very difficult to get some of them apart. And the rebuild kit for the head of this pump is like about the third of the cost of a new pump, and then if you buy the whole head, it's even more than that, and you can just replace it. These things have ceramic pistons or plungers. I'm not really calling them pistons, because this is basically just a check valve type of positive displacement pump. It's really a pump that they use on most of the time on pressure washers, various kind of pressure washers, or or this is kind of, I guess, a more industrial version they use maybe in car washes and stuff like that. Although you can buy pressure washers from places like Northern Tool and stuff, and they do have these cat pumps on them, so they do make more of a consumer versions. But this is more of a commercial type version, I guess you might call it. And so this pump is I think it's 4.5 gallons per minute, and it can go up to 5,000 psi, but my coolant system doesn't run but at 1,000 or a little more than 1,000 psi, so you're not really using that ability. And this pump can put out 5.5 gallons per minute, up to 3,000 psi, so it'll work fine, I think. And the speed of the pumps is more or less the same as far as the speed they operate at. And the motor it has an unusual RPM for a 3-phase motor. It's like 1160 RPM, I believe, if I remember right. on the motor, which is kind of a weird RPM for a three-phase motor. And these pumps will run at that speed. Or maybe this pump was rated a little bit higher speed than that for its output. It was but it wasn't. It was like 1200 RPM or something like that. So it's very close. So I think it'll work all right, and it won't stall the motor. Or overload the motor, which is what I was more worried about, and possibly might put out a little bit more volume than this pump in the coolant system, which would help if that happens, although I'm not that worried about that or anything. But anyway, so this is the old pump, and now I've got to configure this to go on in the chip blaster. Let's look at the chip blaster for a second. Just here, let me pick up the camera. This is a very old chip blaster. In fact, when I called him up for this problem and I tried to get parts, I couldn't even really get parts because the unit has a serial number of 717, which is like they've made thousands and thousands of these since this was built. So they even had difficulty finding the documentation on this particular pump. But the way this works is it pumps coolant from the reservoir, the coolant reservoir over here. It comes down these hoses, and it goes into this pump, and then it pumps it into the tank on the chip blaster here. I'm trying to walk around here. This is kind of tight the way I've got, because I've got this case off of there. And then it takes this pump, and it pumps it into the inlet of that high pressure pump. And then that high pressure pump, of course, goes through a regulator here. I've got this kind of disassembled because there's also a cartridge valve, a hydraulic valve that goes on this pipe fitting right here, this pipe nipple. And I've got it up over there on the bench because I'm going to replace that. I don't know if the valve was malfunctioning or not, but just in case, I don't want to take this thing apart again. So I decided to replace that. You might remember a previous video I made where I replaced this valve in this block here. And so now I'm just going to replace that valve. I'm pretty sure the coil went bad on it. I'm thinking that was my original problem, although I thought it was the pump. And so I started disassembling the pump. And actually the pump did have a few issues. The pump mounts right here, and that's the coupling on the motor that runs it over there. So I think that I really didn't need to mess with the pump, but when I got into the pump, it did have some issues with it, so it's good to replace it anyway. And this unit is like 24 years old, and it needs some maintenance done on it, because I really haven't done much of anything to it. So the coolant gets pumped out of this reservoir by that pump through this bag filter and into the intake of the high pressure pump, and then through that regulator and up into the machine. This regulator is adjustable, but it says, you know, 1,000 psi max on the panel there. Although I need to get new gauges because these gauges have failed as well. This thing's like so old. But these are the pressure gauges for the filter. So if there's a big differential there, it actually has a sensor in the control cabinet, which is plumbed up to this thing here. And it switches something in here. So this is the control cabinet. And it'll sound a buzzer, I think, when your differential gets too high. You need to change the filter. And it may also shut the pump down. I'm not sure about that, because I've never had that happen before. But so this is kind of a relatively simple device in a certain way. This thing is just a skimmer that has belts in there that skims oil off of the coolant. I would tip this up and show you, but I got all these screws and fasteners sitting on top of it. So anyway, I think that this is the best way to go, because I'd end up spending about half as much as this pump cost by the time I rebuild that, and it would take time to do it and everything. And I still have 20-year-old bearings and connecting rods and everything in there, so this is a new pump, and this will work better, I think. It'll just be easier to get this coolant system going, because I got to get this job I'm working on out. The only other issue I had really was the this solenoid valve. Let me show you that here. And I think that this is a new valve, and it's going to go in here like this. And this is the coil that goes on the new valve. But unbelievable is that, okay, Parker, these are just regular Parker valves, which you think would be easy to get, but they're not at all easy to get. This particular valve has a 260-day waiting time on their production schedule, and the solenoid, or the coil, I guess, not really a solenoid, just a coil, had like a 120-day wait time on it. So these are like older items, I guess, and they were kind of difficult to find, and these were expensive as hell. I think this was like $290 for the valve and $219 for just the coil, which surprised me, but I guess it's because of the scarcity of them. And also I paid up for overnight delivery, because by the time I found them, I had to have overnight delivery on it. So that's going to go in this block. This is just a block of steel with a fitting on it that the high pressure hose connects to, and then this valve in here. And this is actually the bleed off hose that goes up to the tank, and this connects on to that pipe nipple like you just saw in the video. So the valve itself might be all right, but I measured this coil, and the coil is an open circuit on that one. And I actually had another coil that I didn't know if it was good or not, but it doesn't measure the same resistance as the new coil, so I'm just going to go with all new stuff here and be done with it. I don't want to mess with it. And this is the coupling that came off the pump, the old pump. I'm going to mount that on the new one. So this should be a relatively easy fix, kind of. All I have to do is take because this frame on this pump is identical in every way to the frame on this pump, and the coupling and everything should just go right on. It's got a 24mm shaft. Yeah, see, it just slips right onto it real good. So when I put these base pieces on here, everything should be the right height for the motor and everything, and so it should be just that I have to mount the appropriate fittings on here like it had, and it should be almost like a done deal. I just have to, I don't know if this thing comes with oil in it. I have to make sure of that too. Doesn't look like it has any in there, just looking at it. So I have to make sure I've got oil in here. See oil residue in there, but I don't see any. There's a little bit of oil maybe just when they tested the pump, but I think they must have drained it later. So let me get that all situated and ready, and I'll come back and kind of do the install and see what we're doing here and see if it actually can get this coolant system to work. All right, let's see, we're going to clean this off here a little bit. This is like 20 years of crud. The way they built that cabinet, it's kind of hard to get in and work on this thing. I had to disassemble everything the way you saw it there. Unmount the tank with the filter in it and everything just to get to this pump. So it's a little bit, I don't know, they could have designed that enclosure a little bit better on the coolant system, I think. Make that a little bit easier to work with. Kind of working on my surface plate here. It's not really the best thing to use for a bench, I guess. but it's handy. So that's what happens. This isn't really a high-grade surface plate anyway, so let me, gotta get some wrenches here. Let me get the tools. This area is all kind of cramped here. I'm gonna assume, I don't know if these cat pumps, okay, yeah, they have inch size screws on them. I gotta look in the box. I didn't notice that this came with a manual or anything, this pump. I might have to go to the Cat Pumps website and download a manual. So I don't remember seeing anything. It's kind of a little bit awkward, this pump. It's like there's nowhere to set it down. All right, so that's the pump, and this is the coupling. It's going to go on to the. There's a rubber deal that goes in between there. Let me get it. I'll show you. Never really seen a coupling like this, but this rubber thing looks like this, and the motor has a similar flange on it, and it mounts in there like that. And that, you know, can go either way, but it seems to have held up nicely. This thing's been running for a lot of darn years. There's a few teeth kind of a little bit worn in here on it. I don't know if that was the motor side or the pump side, so I don't remember which way this came off. So, all right, I checked the service manual, and this is the oil you're supposed to use. And fortunately, I went down to Northern Tool, and they had some of this oil in stock. I ordered some off of Amazon before I went down there, but I saw an ad for it on the internet for Northern Tool, and I said, well, we got a store real close to us here. And I went down there, and they had this on the shelf, so I've got some coming as well. So I have enough to make the first oil changes in 500 hours, according to this and on the manual too. And this size 7 body or crankcase takes 25 ounces. This bottle holds 21 ounces. So it'll take a little bit more, so I got 2 bottles of it in theory, unless there's some residue in there that was left over. Let's see. So it's kind of funny that sight glass, kind of hard to tell it. We'll see here when I pour some oil in it. Now, in reality, on the pump that was in there that ran for over 20 years, I never even changed the oil on. So, I don't know, maybe somebody did before me, before I owned the machine, but I never changed the oil in the time I owned it, because I never had a manual on the chip blaster, and I didn't really know what oil or the intervals or anything like that. I don't see anything in the sight glass yet. Kind of hard to see anything in this set. Oh, there we go, okay. I don't know if you can see that in the video, probably not. We get a lower angle for you, maybe. You can see there's just a little bit in there. I've got to put a little bit more. It's at 21 ounces. I mean, 25 ounces, 21. Got to put 4 more ounces in there, in theory. So let me see. See if I can sort of measure this. I guess it really isn't that critical as long as I can see it up on the sight gauge about halfway. There's a deal on here. In theory, I should take a little bit more. Trying to read this. This is 21, maybe a little bit more. I think I'm going to fill it up to the red dot on the height, on the sight glass. There. I don't know if you can see that. You might not be able to see it very well. See, there you can see it. So that's the oil. That was pretty easy to solution. I forgot all about what kind of oil this thing took. It doesn't come with any oil. So that's done. I sort of have the flange, the coupling just sitting on here. Make sure the key is in there. Nothing. There's a little set screw, a very small set screws on this thing, but I just have it kind of setting on there right now until I get it on there with this, and I'm going to adjust the set screws, tighten them up. And I put the fittings that were on there. There was 2 plugs on this side, and this is the fitting where the inlet coolant comes into it, and this is the discharge side. So I got it all ready. I'm going to take it over there to sort of set it in there and get this coupling arranged and everything. All right, I'm going to bring it over there. Let's see. See if I can set this thing in here. This hose has to kind of go under the base of it. That's the way they had it routed before. So let's see how I can do this. Something like that. And that's the way it goes. I'm going to get my screws that tie it down to the base. Knock the camera down. Let's see if we can tighten these up first. And in the manual, they have a calculation for the pressure and the horsepower, and I could run up to about 1200 psi and still be all right with that 5 horsepower motor. So here I've got to mount on this stuff, I got to mount that solenoid valve
What I think I'm going to try to do to begin with is to go with the old solenoid valve and with the new coil, and if that works then I'm going to be fine. If not, I have the new valve to put in there, but I think it'll be all right. I think the valve was probably all right. I think actually what my major problem was, that coil was bad, and I probably didn't need to mess with the pump too much in reality, but I don't think it hurts to change this pump after 24 or so years of this thing being in operation. So let me get that block with the valve and install that. All right, I just got this on here loose because I have to take these off to get the otherwise I can't rotate that block on there. And this tube has to come off of here. All right, I've got to replace these gauges, but I got to hook the line up where it's going to flow coolant out there, of course. Lines have to go up through here, and they hook to the low pressure side of the filter on each side of the filter. Now the rest of this, unfortunately, that filter's kind of just hanging out in limbo. I got to hook that line, this line here, from there to the intake of the pump. But for some reason, somebody made this panel, and it's got a hole in it, but you got to run the line through the hole, but you got to have that mounted up on the side of the thing in order to mount the filter. And that's kind of a pain in the ass, because it's just you can't, I don't know, it was very difficult to take this thing apart even, because I wanted to leave, I kind of want to leave that filter connected because there's a bunch of coolant in there and it would all leak out. But actually I'd had to disconnect it and drain it down to this level anyway to do this. But that whole canister mounts on this thing right here, and then this hose clamp clamps it to this around this bracket. And so you can't take that panel off the side of this thing here to get to it to do any service with that coolant filter, the bag filter canister on there. And you can't take that panel off because the whole hose is captured in the hole. It's kind of a crummy way to design it, I think. But I was wanting to run this thing without that on there to check for leaks and everything. So I'm thinking about how to do that. Let me think about that. I've got to index some inserts on those cutters first. All right, I got everything kind of temporarily hooked up. Sort of the moment of truth here. I've got to turn on the coolant, and it's got to fill this chamber up, and the pump isn't got any coolant coming to it, so I might kind of, I've got this valve open. This kind of bleeds the air out of this tank, so you see coolant coming through this line here. And I might turn the coolant on and off quick a few times just to see if I don't want to run the pump too much dry.
but I got to get coolant up to it. I had this tape over here so I wouldn't accidentally turn that on because I was working on it and I couldn't run the machine with the coolant off. Okay, here's the moment of truth here. Turn the special coolant, they call it on this machine. Looks like that's working. That's what it looks like when there's no tool in there. There's a big passage, so the pressure might not be as high.
Doesn't look like there's any leaks. Pump seems to be running smooth. These gauges are kind of messed up. I got to get new ones. The needles are broken, but this is about 40 psi across the filter. Well, actually there's 0 psi across the filter. I just changed it. So it's 40 psi on both the inlet and outlet. And this needle's pointing up towards here, which is about well, I don't know. I don't think that gauge works properly.
All right, I stopped this thing in single, in an optional stop with a tool. Took the tool out so I could check the coolant. I got to continue on with this program. So I think we got that going, finally. What a hassle, believe me. It's been a major hassle with this thing. Had to find the parts. I did have to change to the new cartridge valve, the Parker cartridge valve. When I took this out, it kind of split in half the way it shouldn't really. This is the bottom of it. It threads together like that. This has a little spool valve in it. That's pilot controlled with the, the magnetic coil. And it's really a pressure bypass is what it is. It's normally closed. And if the pressure gets up too high, it opens to bypass the pressure back to the reservoir.
So see, this gauge is broken. It's filled with halfway with coolant too, because this top plug thing came out of it, and I guess coolant worked its way in there or something. But I got to get new gauges. So these were up here at about 40 when it's running, and this I can't tell, but it should be around 1,000 or a little bit more than 1,000 psi, I think, on that. So one more maintenance issue, sort of almost taken care of, except for the gauges of the horizontal mill. Special coolant. See, that doesn't really build up pressure unless you have a big unless you have like a tool with smaller passages on it. But I can't run that. That job I'm running takes that big drill, and it goes all the way in up to here, even drilling the holes. So I really need the coolant for that. I can't run it through the spindle coolant, that is. So anyway, that was the deal for today. Get that going. Now I got to go back to this job here, put the tool back in.